And thank you. Dawn is recording so that we can make sure that, any cool information that I go over today that you're like, whoa, that was too fast, but I want to look at that again, we can have recorded. And thank you. I think Kylie, did you help me make sure that we got the video off of private to shared? Thank you very much. Okay, so we're gonna get started. Woo. Workshop 2. Yay. So, as we talked about before, the first week was about R for beginners, and you guys got a little taste of R. Today, we're going to do some more advanced and relevant data analysis. We're going to be using a data set of RNA-seq data and do some work using generating tables and making a box plot in ggplot. And then next week, we're going to make a fun, your own figure you'll work on. So the goal today is to become familiar and comfortable with the basics of using R packages to make reproducible custom tables and plots that are that's a typo, sorry, that can be shared in a report format. So that includes, where's number 1? Okay, going over everyone's bar plots from last time, then providing I'll provide a brief introduction of R Markdown, then we'll learn how to create and manipulate different tables, learn the basics of ggplot, the ggplot package, and then create a custom ggplot, and then make a R Markdown report. And then at the end, we'll talk about the final project. So before we start with the new material, I'd love to see if anyone was able to make their plot. I'd love to see what you all got. So, I'm gonna unshare. No, stop share. Stop share. So, and raise your hand if you made a plot. Awesome! Yay! And that's totally fine. It's not perfect, so don't worry. So why don't is the share screen enabled for everybody?
Is it, can someone test it?
Cool. Catherine, do you want to share first? And please unmute yourself. I'd love to hear your voices. Ooh.
Here's what I got. I couldn't get the x-axis titles correct, but here's what I got so far.
Yeah, that's great. I love your colors, and I like that you changed the orientation of the y-axis from being like really this way to being this way, because that was helpful. And your scale is really good, so you get everything in the table at the same time. Nice. What did you like about, what did you find fun about this process?
I guess trying to like play around with different things and like see what works, but it was like taking a bit, like it was funny seeing it with like every other thing would be an error. I'm like, wait, trying to figure out what was like going wrong. And then like I guess just like going through that process.
Yeah, definitely. Troubleshooting is the majority of doing coding. So great job. Yay. Okay, who's next? Dana?
Yeah, I can show. Yeah, I wasn't sure if we had to make a second, like, little legend for like the names, but I couldn't fit it. So
Oh yeah, I see. So like, well, this is just for one job type, right? The computer science.
oh yeah, I just meant like the names on the x-axis because like
Oh yeah, you could have done that, but also you don't have to, because that would have been like a little redundant. So this is great. It just depends on you if you wanted to like fully write out what all the like, I think for me at one point I like wrote it all as acronyms so it would fit, and then I explained it all in the table, but it's really fine. Nice. were you all surprised by the results, or they kind of tracked with what people expected based off of what we know? Dana, were you surprised by these results?
No, I feel like it was kind of expected, like just based on like my assumptions and my experience.
Yeah. Unfortunately, it's true, but hopefully it'll be changing. Okay, so let's go to next person. JJ, you want to share? Woo!
It's funny that you said it's changing because I had them mixed up. I put the wrong color associated with the like for female. It said that a lot of females were in work, but it was the other.
Nice. Look at that. You're changing the the
I
landscape
just
of
realized that as I was looking at everybody else's, I was like, oh, mine doesn't look that right.
I feel like your results are aspirational. This is great. Yeah, but this is also another great experience of sharing data with each other, because we all can like in a happy, nice, welcoming environment be like, oh wait, this is a little bit wrong. I gotta change this for next time. So this looks great though. And I like how you included both legends as well. So what did you enjoy about this experience?
Just playing around with it. It was like it was hard at first. It took me like a whole hour to figure out how to get it to like do the acronyms at the bottom, but
Mhm.
I guess it was fun just playing around with it. How do you delete? I had to figure out how do you delete like legends? Because that was a hard thing. Because I had to keep going back. Like, can you do something that says delete this legend or no?
What do you
Like
like the
so,
one
like I would
that's
put. So I was trying to figure out where to orient. You know how you put like top right, center.
yeah.
Like I would put center, and then I would be like, ah, that doesn't look good there. But then I'd have to go back to like the original one. Could I just like delete it off of or no?
Like from the
From the graph.
no, you have to change the code and then rerun
Oh,
the
okay.
code. Yeah.
So you
Yeah,
can't
good
just put
question.
delete
There's a lot
like
of just like rerunning. But today we're gonna learn about, instead of having to like print the plot and start over, we're gonna be using R Markdown, which you can do more like it's more iterative. So you don't have to do all those extra steps. You just kind of you can update it as you go.
okay.
So that's the more fun version. Okay. Who's next on my list? Katie?
Hi, I am working with some technical difficulties today, so I'm actually zooming in from my phone. So
Oh,
unfortunately,
okay.
I don't have my computer, so I'm just trying to like pick up as much as I can from looking at other people's screens for
Yeah.
today's workshop. But sorry about that.
No
Thank you for your
worries.
patience.
Are you sitting with someone's computer though, so you can like
I
look
am.
on?
I'm like right
Okay.
next to Catherine. So.
Okay. Sounds good. Don't worry about it. And if you want to email it to me later, I can look at it too. So that sounds good.
Thank you.
Kylie.
All right. I had a lot of trouble getting it started, so it isn't very good here.
Don't worry.
So I didn't even get it to a image. Wait, can you see that? Yeah.
Well, you have the data, which is the most important part.
I do, yeah. I had a hard time with the files. They weren't opening on my computer.
Oh wait, yeah.
But now,
Because
wait,
we can't see.
oh gosh. New share? This. Now can, oh.
Oh, there it is.
Clearly I'm not very good with technology, which is really the problem here.
No.
Okay, but I was just proud that I at least got the plot. It just isn't pretty or what it's supposed to
Yes.
look like, but
You got it. And
that's all I have.
you're going to be able to make those changes like we were talking about with your axes and adding a header. And I think now that you got this going, you'll be good to go. But do you have any specific questions you want to troubleshoot now?
I guess the thing is I was able to produce it. I have a lot of error codes. Oh, wait. But I mean, I could talk to you maybe later, but
Yeah.
I guess I was just having trouble making my own R script and like to do the functions that I would like.
Yeah.
I don't
if
know. I'm
you
actually just kind of
ex-
lost.
Yeah, that's okay. If you X out, just so everyone knows how to make their own R script, so X out of this image
Okay.
and then share your
Oh, share the other one.
posit.
Okay.
So if you go to file, sorry, on the top left where it has like the little plus sign.
This one?
Yeah. So you can do R script on the top.
Oh,
Yep. And that'll make your own new R script. So you could just like copy over the code and paste it into there if you wanted to start
oh,
working in
okay.
there.
And that will directly change it on the box plot, right? Because it's what it's set to. Or wait, what's the R script for?
Oh,
again?
it's kind of just like I was just trying to give you guys like a okay, you can so if you go to this SURP for beginners bar plot script,
Mhm.
and then you go, yeah, so you could just copy this like from line 63 to 74.
Okay.
And then put that in your new script,
Oh no,
wherever it went.
that's a great question.
I think Untitled 1.
Oh,
And then paste it in
what? Just
there.
paste it.
And so this is just like then you could name it, this is the bar plot about this thing. It was more just like a different file. You didn't necessarily have to do it that way, but that's what I meant.
Oh,
by
okay,
script.
gotcha. Okay, I'll work on that then.
Yeah,
Sure.
we're gonna learn how to do all this in our Markdown today, though. So maybe after we learn that today, you might want to transition into our Markdown, but you can wait and see. But I'm
Okay.
happy to talk to you more about it after too.
Okay, sure. Thank you.
Yeah. Okay. Last but not least, Will.
Save the best for last, right?
Best for last. Woo!
So the only problem that I had was just like shortening for acronyms. I wasn't sure how to do that.
Yeah.
But I could
Yeah,
change the font
I
size,
can't-
but I just needed to.
Yeah. That's okay. What did somebody do for shorten to do that could help Will?
I think it was just like shortening because I did the practice graph and I was able to like figure that out how to make them
Mhm.
like that, but they weren't even. They weren't like matched up when I originally like with the full name length. So I just needed to like figure out how to like shorten them to some way, but I wasn't positive.
Yeah, so if you do you have the code out?
Um,
Otherwise, this looks wonderful. Great job.
let's see. Hang on. Wait, I think this is it.
Okay, so if you go to the in the script on the top, do you have it like down somewhere?
There's like four. I have like four of them open.
Okay, so the part so that you were working in.
Oh, okay, I guess. Sure, that's fine.
So see where it says names?
Yeah,
You could just change this part. Is
okay.
that what you did?
Yeah, I just was like, I think I know how to do it. It was just that I wasn't positive on what to shorten them to.
Oh, got
You
it.
know
And
what I
actually, I
mean?
think I was wrong with what I just said because this is for your legend, but
Yeah, this is for the practice one that I did. But like I just wasn't sure on how to shorten, like what to shorten them to.
oh, okay. Yeah.
That's why I didn't
Play
want to.
around with that. Feel free to update me once you get it shorter if you want to.
Okay.
Cool. Great job, everyone. Woo! Yay. So, any questions before we move on? Cool. Today, oh, these were mine. Woo. Oh, yes. So this more same colors as well. And then similar to JJ's had the little box here. But today we're going to start, I keep talking about R Markdown. So what is R Markdown? R Markdown is a document format, which is kind of cool because it combines the features of different types of languagey things with R code as an output. And it allows you to create, like I was trying to say, dynamic documents. So instead of having to like write your code, print it, and then like there's all these steps, you can actually like you do your code and then it like prints below your code so you can see what you're doing as you're going. And then it allows you to have this like nice printed document at the end. So this is what those symbols look like. So why do we use R Markdown? The main thing that it's really good for is reproducible research. And I'm sure you like learned about this throughout your research experiences and maybe in class, how important reproducibility is in science. And it's very important for all stages of research, including like computer science, data analysis, biological research, et cetera. So using R Markdown, you're able to generate reproducible results. And then, like I was saying, it's dynamic. So it makes these really cool reports that integrate text and figures together instead of like exporting a figure, downloading it, putting it into a PowerPoint presentation or putting it into a Word document. It's all in one, which is really nice. And then there's some other elements that are a little beyond the scope, but it provides interactivity and collaboration and sharing that you can do. So we're going to focus on the reproducibility aspect and dynamic aspect. And what does it look like? So you already are a little familiar with how codes work in R, right? We have our functions, we have objects, and this is an example of a different type of plot. It's called a Q plot. And so in R, you can generate, like you can run this code and it'll like print out everything in this really pretty format instead of looking like code format. So we're going to start working on this in Posit. So what I think I'll do is, oh, I should keep sharing my screen. Oh yeah, so what we're gonna do first is open Posit again, start a new project. You can call it like workshop day 2 or something. And then we're gonna learn the basics of our Markdown commands, the basics of commenting, and how to make an R Markdown report. So let's get going. Is it hard for you guys to go back and forth between what I'm working on and you're working? Like, is there somewhere that we could put this on the screen or something? Or how does any feedback on how to best present / you guys do work at the same time? No? Thoughts? All right. Well, I'm going to start a new R project. So everyone else can do the same.
So we've been just like swiping back and forth between screens. So we can
Okay.
like swipe over, see the code, and then swipe back and see you and your code.
And it's okay? It's not
Has that been
terrible?
fine for everybody?
It's complicated and tiny, but it's okay.
Yeah, it's doable. It's not doable for me because I'm on my phone, but as the spokesperson, it seems like it's working for people.
I'll
Okay.
come into the office right now and put the code. I will project this from the screen, and that might be easier for you.
Could you do that? That would be amazing. Except for poor JJ. Sorry, JJ.
I just have the Zoom, like I have a split screen, so
Split screen? Okay,
yeah, so
cool. Thank you, Don, though. Okay, so everyone title their project for the day. We'll do like our workshop day 2. And so everyone's familiar with the environment. we're gonna do something a little new, which is the R markdown. So the same location that we saw where the R script is, we're gonna start working with the R markdown. So you are gonna have to do two things. It's gonna say R markdown requires updates, so you have to say yes. And it's gonna do some updating of files and packages. So that's normal. Shouldn't take too long. In the meantime, I will share some of the files we're going to be using today. Okay, not in the meantime, because now we're done. So then it's going to ask you to title your project. So we'll call it, I'm just going to end up calling everything workshop day 2. So we'll just say SURP our workshop day 2. And then you're the author. So put your name here. And keep it in HTML format as the default output format. Any questions before I press OK? Is anybody not here? Speak up because I can't see everybody. All right, so then you should get a display that looks like this, where at the top it has the title, author, date, and output, and then there's some other information down below. Alrighty, so our markdown, like I said, is a way of integrating code, figures, and text. So whenever you start an R markdown document, it's going to give you this default information. So you'll see there's different, they're called chunks. And the way that R markdown needs to be formatted is in chunks. So it always starts with the /// and then there's the little bracket, and then it closes with ///. So if you want to run a chunk, you click this little green arrow. If you hover over it, it'll say run current chunk. So that doesn't actually do anything. It's just like kind of showing you setting up the information. However, if you move down to line 18 to 20, if you run that chunk, it's going to display some information right below that chunk. So it's telling you based on this data, which is cars data, using the function summary, it's going to tell you this the summary of the speed of this data of the different cars, I guess, that's in this data set, and the summary of the distances that data, those cars go. I'm actually curious what is going on with these cars. So if you type in view, okay, if you type in view of the data set, there's only 2 columns. So it's telling you the speed of a bunch of different cars and the distance those cars can drive. And that it's summarizing that information. And then you can also, that's like data and stats related, but you can also do plotting. So if you run this plot function on this object pressure, it creates a plot right below the code. So it's showing pressure, whatever that's supposed to mean, for different temperatures. I don't know what the pressure is for exactly. So this is just an example of how it gives you this little like quick tutorial, but we're not going to use any of this. So you can delete all of that because we're going to make our, oh, sorry, don't delete yet. If you delete it, undo. I want to show you how to actually display the output. So whenever you want to make your report, you have to use this knit button here. So you just click the knit button and you're going to save your file again. I know it's very annoying, so we'll just do like the same thing. So SURP our work. This is the last time you have to save it. workshop day 2. And you can see in, well, you can see in the files now, you have an R markdown, that's your code, and you have an HTML file, and that's what you just generated. And so you can see how pretty this is. It's telling you all this information. So it says like, this is the name of your file, this is who made it, this is the date it was made. And so this is like that reproducibility aspect. And then it's telling you information, it's telling you the code that was run, and then it, prints out the results, and then it tells you like the plotting, and it prints out results. So that's what we're going to do today, is make our own output report. So now you can delete all of this stuff. I think just from line 12 down.
I'm about to head out. This is being recorded, right? So I can watch.
Yeah, it's being recorded, and then I'm also going to be sharing the files we're using today. So I'm going to put that on the GitHub at the end, and I'll share it with everybody.
Okay. All right. Thank you.
Yeah, have a great day. Okay. So I'm in the habit of always saving, but it's because it's on the web, like on the cloud, it automatically updates, but that's just my habit. But I'm going to share the files now. Any questions before we start? While I'm starting to find files. Come on. Zoom. Give me. Okay. Okay, I'm going to put it in the chat. So we have I'm giving you 3 files. And so who remembers how to upload the files to the R file environment?
I think I remember. Oh.
Okay.
Oh, that's. Just keep talking. You're fine. It's. I think the. Heck. Oh, you know what? I'll just talk it up there. Hold on.
No, I don't hear anything.
Okay. Okay. So. I think you're gonna use the upload button,
Yes.
like that one there. Choose file, and then select the file that you just set in.
Yes, exactly. So I put mine in this folder. You guys have it downloaded wherever you have it downloaded. So, and then you just upload one file at a time. So let's get all 3 of those files uploaded. Oh, great.
Sorry about that.
No, it's okay. I just wanted to make sure. Okay. So, can I get like thumbs up if everyone's has their files uploaded? No. Okay. Got 1 thumb. Can we get some helpers if anyone's having trouble? Oh, I'm gonna add 1 more file because I think it'll just make life easier. Sorry to do this to everybody. I'm gonna give you the R markdown that I made. because I think that just might be easier. So if you upload that, we'll just open that now, and then you'll change it to be your name. So it's going to be confusing because now there's two SURPs files. Okay. Are we ready to move on? Dana has a thumb up. Catherine, are you good? No? Can I help in any way?
I just can't like upload them. Like when I'm like I've successfully downloaded them, I can't find them. It's a personal like I can't find them.
Oh, you can't
working
find it
on
on your computer?
Yeah.
Oh no. When you download, does it ask you where to download it to?
Yeah, and I put them to my desktop, but then when I went to upload them and like go to like the files in my desktop, it says it's not there. So I'm just trying to find where they are. So I'll figure it out.
Do you have a PC?
Yeah.
Yeah, you can maybe like search in the search files option, like on the bottom left. Can you search for the file names? It's like RNA-seq _.
Yeah, I think I'll be able to find them. Or just
Okay. If you can't, like right now, you feel free to look on with somebody else. Okay, so if you open this R Markdown, you'll see the author. So change it to your author name, because this is yours. And then you'll see that I have the first chunk is that same chunk I had before, which is when you're knitting, you don't want to print the knitting information. So that's what this is saying. It's just saying to like keep that part silent. But now we're going to get to know the data. So that is step 2. We're going to make tables. So we're going to first upload the data and then read it in, and then we're going to get to know our data and then try out different table options. So if you recall, the way we read in a file is after it's uploaded into our environment, well, not the environment, into our like file cache or cache, you use the function read.csv. And so we have 2 different files we're reading in, RNA-seq _data_1 CSV and 2 CSV. And I'm going to call it dat1 and dat2. So I don't know if I mentioned this last time, but if you use the command enter, didn't we talk about this last time? Okay, if you use command enter, you can run that one line. And if you have like your code all in a chunk, all you have to do is press the run current chunk, and then it does everything in that chunk for you, which is very nice. And then also you can see that when you go down a little bit, it's showing you using this head function. It's showing you some information. So what do you think the head function is doing?
It looks like it's giving you like a nice view of what you'd be looking at if you were in Excel or something. Is that?
Yeah, definitely. So I guess I didn't include, oh, that's not the next section. So the next section tells us the dimensions, but the function head, and we can find out more by typing in question mark before the function. You can always look up what a function does by typing in question mark before it. It says returns the first or last parts of a vector, matrix, table, or data frame. And so it gives you like the top 6 lines of a data set. You can see that. It doesn't print out the entire data set. It just gives you a little peek at your data, which is really nice because maybe there's nothing there, or maybe it turned to like another language by act, and like something went wrong. So that's cool. And you can see we have 2 data frames because we looked at data set 1 and data set 2. So let's learn a little bit more about what our data is. So if you run the dim function, that tells us the number of rows and columns in that order. So this data set, data 1, has 3,048 rows and 15 columns. You can also see that information in the global environment over here on the right. So when you read in data, like what we read in this file here, to an object and save it to an object, it will store that information in the global environment. And you can see that there's 3,048 rows and 15 columns, or they call it observations and variables. And then if you click this little arrow here, it'll tell you like what all of those variables are. So we have gene ID, gene name, etc. And you can see that from the head as well. And you can actually scroll over to all the columns. So it's pretty interactive. It's very nice. So that was dim. And then another function we're going to learn is call names, which is very helpful because it tells you what are all the column names of your data set. So now we know we have gene ID, gene name, and then we have a bunch of other things. So that's helpful information that we're going to use later. But I didn't run the whole chunk together. So I'm going to now run the whole chunk together. And so it's going to print out the dimensions first, and then it's going to print out the column names. Any questions before we move on? Ask me a question.
I think I'm doing pretty good right now. I'm so glad this is recorded because it's like I get a preview and then I can try it later.
Yay! Anyone else? Dana's feeling confident. Will, how are you doing?
Dimensions? Is that like number of rows, number of columns?
Exactly.
Okay.
Exactly.
And then I guess that means that all of the spaces are filled. So in your actual file, there's no blank boxes.
So there may be some blank like cells. That's going to be something that you'll have to account for later. It may be just empty cells. It may be, they say NA if there's something that doesn't have a value, or it might be like they put a 0 in place if there's nothing there. So it depends on what the data is. And that's something you might have to deal with at some point. Today's data is a little curated, so you won't have to worry about that today. All right, so let's start looking at tables. The first table function we're going to use is a summary. We kind of looked at that already in the sample. So if you run this first line, I just want you to see what it looks like. So Dana, can you explain what this function did to the data?
Sorry, I'm eating.
Oh, no, sorry. I don't see your like little icon, so I didn't notice that. Sorry.
No, it's okay. So it looks like it just like summarized like, yeah, okay. There's like the minimum, the average, and like the quartiles of all the data and the maximum.
Yeah, do you remember what this $sign is? And like if we're looking at the data itself.
Yeah, isn't that like to like kind of like call it or whatever, like specify within the data set what part you want?
Exactly. So we're interested if we view dat1, we're interested in looking just at the summary of this column, BC_1_FPKM. And so I'm curious to know like what the minimum value of this column is, what the maximum value of this column is, just the summary information of it. And so yes, if you want to look at a specific column, you would do dat_1 $sign. And if you're typing it into the console, it'll actually show you what all the different variables are. which is really fun because then you don't have to type it all in. You just like pick one and press enter. So it'll print it all out. So, well, I'll show you. Yeah, it prints them all out. So, sometimes don't always print that because it might take a long time to run. So now that we did that summary, why don't you do a summary on the gene length? So can someone tell me, let's see, how about Kylie, can you tell me how to summarize the gene length of the DAT1 data?
I'm not sure how you do that.
Okay, well, how would you start, do you think? That's fine.
Okay, hold on, let me see. I really don't know, to be honest.
That's okay.
I'm
Can
just
someone
really
help
trying to
guide
follow
you?
along the best I can.
Don't worry, don't worry. I didn't mean to like call you out, so don't
Oh,
worry.
no, that's okay.
Who can help us out?
Could you like basically copy and paste that line of code from above with the summary parentheses dat and then change what comes after the money sign to be the gene length?
Yes, so let's
Okay.
type it out because it's always more helpful. You can, when you start getting more practice with this, you can definitely just copy and paste, but I always find it more helpful to type it out so I learn better. So if you do summary DAT1 and then $sign, remember what I said, how you can see all the different variables now. So if we're interested in the gene length, we just go down until we find gene length and press enter. So now on line 44, it should summarize the gene length for this data set. So I'm going to run this chunk now. And so now we have two. Do we have two? Just one. Two. We have two different, yes, results. We have the results for the BC_1 FPKM, and we have the results for the gene length. So there's nothing special about these two columns. I just chose them as examples so we could get familiar with the function. Any question about summary function? When could this be helpful for you? Can you think of any example in your lab where this might be helpful?
You might have two columns that are like the same sort of measurement, but for like a control and an experimental group. And then if you're able to summarize it, this can give you like a quick basic overview of what you can expect to see.
Yeah, this is really, yes, exactly. That's a very helpful, like just quick way to see like, what is my data? Sometimes I end up with data that like is all zeros and I'm like, something's wrong here. And so then I realized that like I entered the data wrong or I'm using the wrong column or something. And so it's helpful to just get a quick check. Did you have a question?
Yeah, when you were talking earlier about having empty or like NA cells in your data set, is this a spot where you might be able to spot that early on, like to see if there's a formatting issue? So if you type it in, it like gives you an error code. Could that be a possible explanation?
Yeah, that would be something where it might just end up being like just all zeros or an A or something. Sometimes though, if there's NAs, it'll just ignore the NA and it'll give you the results based on everything that's not an NA. So you have to really decide what you're trying to analyze there. Good question. All right, now we're going to use the table function. This is one of my favorite functions. So table is going to, so we're going to use the table function on the chromosome column of our data set. And I'm just going to run it and you're going to tell me what it's doing. So Catherine, why don't you tell me what this data is doing? I mean, sorry, this function is doing.
It looks like it's taking like the data that was previously maybe in like one column and is like organizing it into like by like taking the title and putting it right below it instead of it being like in a larger set, I guess.
Yeah, so if you look at the table, I mean, the big data set, we have 3,000 rows, and in every row, there's a different chromosome. Not a unique chromosome, but like we see 11, then 1, then 1. So like every gene is on a different chromosome, as we know. And so what that table function is doing, it's basically collapsing all of those rows based on the chromosome variable to tell you how many genes are found on chromosome 1, how many genes are found on chromosome 10, and so on. So this is a cool snapshot because what we see is like the majority of genes in this data set, the maximum, are found on chromosome 19, which is really strange. I wouldn't expect that. So it's just another way to like get an understanding of your data. Another thing we can do is we can count the number of gene types. So you can run table on the variable gene type and see what types, like what the distribution of our genes are. So you can see the majority are protein coding. Then we have a lot of pseudogenes, and then we have a lot of other varied thingies that I'm not super familiar with all of these. So, we'd expect that the majority would be protein coding. And then there's some link RNAs and pseudogenes and then intronic. So it's just helpful to understand your data. So we're getting to know our data. All right. Now we're going to use the function summarize. So, well, it's actually the British version. So with an S. So everything I've shown you so far has been using built-in R packages, but there's a lot of packages that are not built into, like, it's called base R, and you have to load those. So if you look at the top, maybe does everybody have this yellow strip at the top that's like, hey, these aren't loaded? So click the install button now, because it's going to install all the packages we need. It always makes me feel so satisfied when it's like, look at all this stuff I'm doing for you. Your little worker bee behind the curtain. Almost done. Cool. So when it's done, so what you have to do, there's always this combination. You install a package and then you load the package. So we just installed the packages, but we still need to load the package. And the way you load a package is by using the function library on whatever package you want to use. So here we want to use the package dplyr. I call it dippler, but I think it's supposed to be pronounced a dplyr. And so you run the function library dplyr or dippler. And so now, like, you can imagine we have this library on our computer or in the cloud here, specifically that stores all of our packages. And actually, if you go over to the packages tab on the right here, because we're in files and you click on packages, it shows you all of the packages that you currently have access to. I think that's what the check marks are. Can't remember. So for example, dplyr is one of the, it doesn't matter, it has a check mark, but there's a bunch of different ones here that are in our packages now. So now we're going to run the summarize function. Now there's some new notations that are unique to dplyr. This, what is this symbol? %, is an notation for this specific package that tells us like, and then do. So basically what we're doing is we're starting with our data set here, dat_1. So it's like start, if you're like writing a sentence, you would say, start with my data set and then group it by chromosome. And then summarize that data by the mean of the gene length. So we're going to calculate mean gene length and by the total sum of the gene length. So I'm going to print it out and then we'll see how it actually works. So everybody run this chunk. Oops, run the first chunk. Okay, so let's look at the first one. So you can see that we have all of the chromosomes on column 1. So it grouped by chromosome. And then it also calculated the mean of all of the lengths of the genes for that chromosome. And then it also just like took the total length of all of the genes combined. And so it saved that data into summary_data. This is a new object. So if you type in your console view summary data, you can see that it displayed more clearly. And something fun that you can do is you can sort by minimum and maximum like you would do in Excel. So we could see that the protein coding have the largest gene lengths, for example, overall. Which is, oh, this is not the right data set, sorry. We'll call the data set on line 61 data set 1 and then call the other one data set 2. That was a boo-boo on my part. So then if you view data summary data 1. Okay. Chromosome 15 has the largest, the length genes. That was a lot of information. Well, did you get this far or were you stuck?
I think I'm good.
160. Okay.
Yeah, that way you don't say both.
Okay.
Yeah, that way you don't say both.
Okay,
I'm good.
that was a lot in a short amount of time. So I just want to make sure everyone's on the same page. Okay, so then well, if you're good, will you talk me through what's happening in this section?
Okay. Let me just. This is summarize the gene length, right? Or the gene type. Oh, okay. It looks like kind of similar to what we just did with the chromosome, but this time it's gene type.
So what will we expect to see in the results?
Like a data set corresponding to the DAT1 or the DAT1.
So what will column 1 contain?
Will it be the type of gene?
Yep, that should be it. And then column 2 would be
it'll be the gene length.
and column 3. Oh, not just the gene length. What is the actual math that's happening here?
Oh, the mean gene length, and then the third column will be the sum.
Perfect. Yes. So when you run that code, you get your summary data 2, and then you can see it displayed below here. So exactly like Will said. Very, very cool. So you could see that this would be really useful for whatever research you're doing. I actually don't know what you guys are working on. Could we just take a little pause and everyone give me like one sentence of what you're doing? I'll start with Dana because she's first on my screen.
Yeah, I'm doing prostate and bladder cancer research. So I'm looking at PARP inhibitors, which is like a protein inhibitor, and then in combination with chemotherapy.
Do you use, is it mostly cell tissue culture research?
Yeah, it's all like tissue culture stuff.
Okay, so you would get like case controls and like want to compare the results of something, right?
Yeah.
Okay, cool. I'm just thinking, so like when we do the projects, like what you all might want to work on. Okay, Will, what about you?
Doing research on angiogenesis with corresponding to like cancer and like development of tumors and how that kind of affects it with the particular protein.
Is it cell culture work too, or is it like biochem? What are you working on?
More biochem. Cell cultures, they're kind of, my lab's kind of doing other stuff in cell culture right now, but they're at the point of just kind of, it's like more like biochem research. It's a lot of like Western blots, unfortunately.
Okay, so you could like take the quantification of your Western blot bands and like see like the difference in band sizes or something. That might be something you're interested in looking at.
Mhm.
Okay, cool. Katie, what about you?
I'm doing retinas this summer with Dr. Philp. So we've got some mice that have been genetically modified to have certain genes knocked out, and then we do different things like stack them, run different protein assays on the retina or the RPE, or we've been doing some staining. So I've gotten to see, the eyes get sliced up, we stain them with different things, and you get to see it under the different wavelengths, and it's beautiful. So that's what I'm doing this summer.
Nice. Yeah, it sounds like you also have some different projects you might want to make some cool plots out of. Nice. Catherine.
So the lab I'm in does lymphoma research. My specific project is looking at like one drug and seeing like its impacts and effects. So
Oh,
like,
nice. So you
translation
could
inhibitor.
maybe see like on different cells or on different like, yeah, what on what?
So I do so there's multiple different stages of it. The first part is like keeping them in culture and seeing like the different doses and the vitality of them. And then that's like, I think I'll do it through different cell lines, and then I'll want Western blots to analyze the proteins in each of the doses at each of the time points.
Oh, nice. So you might want to do like some line graphs or something to represent those results.
Yeah, definitely.
That would be cool. Okay, Kylie.
I'm working in Dr. Mahoney's lab, who's also collaborating with Dr. Snook's lab. I'm working on a CAR T cell project that it started as a CAR T, but now we're looking at, instead of putting like a single chain fragment onto a CAR T cell, we're looking to put it onto an exosome instead, to reach different solid tumors that a CAR T cell may not be able to reach. So I've been doing I just finished the subcloning process of that fragment to put on the exosome. So I've been doing a lot of PCR just to check if the plasmid had taken up the construct that we made.
Nice. So you're measuring like the amount of like construct, right? Is that you're like that is in your sample?
Yes, to see how much we have to put onto the exosomes.
Okay, cool. Yeah, you might be able to use like make a plot representing that if you're interested too. That's cool. Thank you. That was a nice little pause. Appreciate it. Want to make sure this is useful for all of you all. All right, last step, we're going to use, it's also in the dplyr package. We're going to use the join function. So there's a couple of different variations of the join function. So let me just do the question mark join. So you can see that there's inner join, which only keeps observations from X that have a matching. So if you have two different tables, so we have dat_1 and dat_2. And what we're going to do is join them together because they're very similar, except one is from one experiment, the BL experiment, whatever that was, and one is from the DL experiment. No, sorry, the BC and the DL. and we want to combine them together into one table. So we're going to use this really useful function called join that's going to bring those two together. So let's look at these two data sets first. So if you in your console type, which we did it at the beginning, but dat_1, you can see it's all the BC data. So we have 3 different replicates for BC, and then 3 different replicates for BC doxycycline, which I think is a knocking out of whatever the BC is. I don't remember exactly what this data was representing. And then for data set 2, you see that instead of BC, it's a different experiment. They were looking at DL in replicate, whatever DL is, and then they added doxycycline to see how that affected their experiment. I think they were knocking out a gene. And so we have 2 separate data sets that are exactly the same except for the experiment. And so we want to merge them together. And the way we can do that is using join. And so we can use inner join, left join, right join, and full join. So they all have slightly different like uses, but I'll just show you how we use it for left join first. So the syntax here, the way that this is explained is that we're going to use the function for data set 1. We're going to join data set 1 to data set 2. And then you need this argument. It's by. So we're going to join it by all of the things it has in common. And it has gene ID, gene name, chromosome, strand, start, end, length, gene type, and gene description in common. So if you run that, you end up with your data set now all joined together. So I'm going to run it on inner join as well. I was just including this to show you that in this case is the exact same result, but in some cases it might not be. So I don't have to get into that today. But now if we use this function call names again, it's going to tell us all of the column names. So what is a little unhelpful about how this data set was joined together? What could we do? What might we want to do to fix this data set? It's just aesthetic, but how could you make this data set prettier based on the column names? There's not really a right answer. There's just how I prefer it answered. Let me show you how it looks as the data set. So we're going along and we have the same starting data that we had before. And then we end up with gene type and gene description. And then we have the data set 2. What could we do to make this a little prettier? I think you must be telling me the answer with your mic off because I can't hear you.
Katie's having some technical difficulties.
Oh no, what happened?
She'll come back in a sec.
Cool. So in this case, and there's nothing really wrong with it, but the gene type and gene description are just like right in the middle of the data set. And I might want to put it just at the end of the data set. Is everybody okay? Should we take a pause?
Yeah, sorry about that.
We're good.
My finger slipped and then it had me on driving mode. So I had to leave and come back because I'm not really sure what happened to my phone, but
Oh, that's
here I
okay.
am. But yeah, that
Okay.
makes sense. You want to put the words on the end.
Yes, so if you want to, in order to do that, this is just an example of like what you might want to do. You can reorganize your data based on column. And so the way you do that with the data frame is you start with these brackets. So you start with your data set that we made, and then in a data set, so it's, I think I said this last time, the brackets are like, everything in it is the entire data set. So in the bracket, you have a comma, and everything to the left of the comma is a row, and everything to the right of the comma is a column. So here, because everything I'm showing is to the right of the comma, we're interested in the columns. So I'm reorganizing this data where I'm going to use columns 1 through 13, comma, columns 16 through 21, comma, columns 14 through 15. And so in that way, I'm able to reorganize the data. And so if you scroll over, we see that that is now the gene description and gene type are at the end now. Okay, so that's just some fun data manipulation. So I'm gonna show you all how to calculate row means and standard deviation, and then I'm gonna let you finish it out and write your table. So we're gonna rename a new data set, data new. And so a function to calculate the mean. So in this case, we want to, you know how we had 3 replicates of this BC experiment, BC 1, 2, and 3. So we want to calculate the mean of those replicates and put it in a new column called BC FPKM average. So to do that, we're going to do row means dot new bracket. And so in the column section, we're going to do columns 8 through 10, because that is where the BC 6, 7, 8 BC columns are. And then when we do that, it saves a new column with that average. And then to do the standard deviation, we do a similar thing, but we use a different function that's called apply. And so when you look back at the table, nope, we have a new table, right? Data new. No, that new. You can see those values are calculated at the end of the table. So why don't you all take a couple minutes and fill in the results for the rest of these, which are on lines 102 to 107. And Katie, you can work with someone else, if that's okay. Who are you working with? Cool. You and Catherine can work together. Great. While you're working on this, if anyone has questions, I can answer as you guys go. Does someone want to get us started so that I don't know if people like know what they're doing or not? Oh, sorry. What would you do here for BC docs? Catherine, you look like you know what you got it. I know what I'm doing.
Oh
face.
no, that is not the look at all.
Could you do, if you summarized it again, wouldn't that spit out the mean of BC docs along with some other stuff?
You would, but we're just really trying to add new columns to this table with
okay.
all of the averages and standard deviations. So we did this for the BC, and we made a BC FPKM underscore average column, and that's here. And so now I'm asking, can you do that for BC docs? And so you might want to do dat new dollar
I think I
sign.
might be able to do that.
Yeah, what would you do?
But wait, go back, Catherine. Where? So I can see the other thing. Okay, you know what? It might be on my phone. Okay, so you're gonna do dat underscore new
Mhm,
dollar sign,
mhm.
and then which column did you want the mean for?
So this is where assigning, we want to like say this is where it's gonna go.
Can I phone a friend?
So we're making a new column that doesn't exist yet. So we're calling it BC docs FPKM average. So this is our new column. So what are we gonna put in that new column?
Is it gonna be row means?
Row means, yep, of what?
Of dat new columns all?
Columns all?
I'm not sure about that.
Okay, that's fine. What are we taking the means of, Will? In this
Say that.
example?
This is the one, the last one was BC, so this one's BC docs.
Yes, so
So
which
it's-
column numbers might those be?
Okay, I'm trying to figure it out. My thing keeps refreshing randomly and I keep like
No.
losing half of the stuff, so I'm
Well-
like at the place, but the column I just can't see.
What, can you see the bottom of my screen and just read off the numbers?
That one, I can see it.
Yes, okay, so it would be 11, 12, and 13, so it would
Okay,
be
and then the
11.
notation in R, we can just use a colon to the last one. So we'll do 11 to 13.
Okay,
Great. And then we'll just do this one together too now. So how do we set this one up if we want to calculate the standard deviation of BC docs?
Okay, I think I'm gonna do it again. Okay. Wait, is somebody unmuted? No. Oh, Willis.
Oh, okay.
So
So are you gonna do dat new number sign? BC docs. FPKM underscore standard deviation,
Great. So that's our new column
Equals-
name.
great, equals row standard deviation. Parentheses,
say
dat
above?
new, and then
What
the
does
same
it-
columns.
So row SD doesn't, that's not a function that actually
shoot.
exists, unfortunately. So we have
That's
to
tough.
use a different function. It's called apply.
Okay. Okay.
But I
apply,
like your thinking.
parentheses, dat new. And then shoot, brackets, comma,
Mhm.
C 11 to 13,
Great.
brackets, comma, SD. Or is
Yeah,
it comma one?
in this
SD?
case, we need to use this one, which I have to remember why we're using that, but this will definitely work. And great, you guys calculate your new mean and standard deviation for BC docs. So do the same thing for the others, for the DL and then the GL docs. And then we'll be ready to save that table and then output save that table, and then we can move on. Sorry, your page keeps refreshing. So when you're done with that, you can just, if you remember how we learned the function to write a table, you do write.csv. So you could just run that chunk when you're done and it'll save your file as my analysis. Very helpful.
Can you scroll back up to that line you just wrote before?
Oh yeah, of course. Here you go.
Thank you.
Yeah. And please ask more questions if you have them.
Wait, I have a question, like for the standard deviation one, like the apply function. What
Yeah.
are like the stuff after it? Like you have like that new and then like the brackets, like what's like the one and like the SD, like what do those do?
Great question. So let's look at the apply function. So the apply function, yeah, what is the one? I don't remember what the one is, but the SD is like the type of application that you're using. So there's a bunch of different ones you can use. It doesn't only do standard deviation. It can do, it's not providing all the information here, but it can do like sum, or it could do other types of statistical things. And so in this case, it's doing the standard deviation. And I think it might be the first standard deviation, and that's why it's 1 instead of like more, but I would have to double check and let you know because I forget why it's 1. Stats is not my strong suit, I'm sorry to say. Oh, let's see. Matrix 1 indicates rows, 1 indicates rows, 2 indicates columns. Great. So we're doing this on the rows because it's, if we wanted to do the standard deviation on the columns, we would do the we would put the number 2 in there. Does that, yeah. Thanks.
I can't.
Great
I'm so
question.
Oh.
Everyone up to speed? Saved their file? My analysis should be in your files. But remember, this is just on the cloud. So if you want this table for yourself someday, for any reason, you would need to download it. And to download it, you click it and then export. So you don't have to do that now, but if you wanted to. All right. So for the next 10 minutes or so, we're going to do, oh wait, we're done at 12, right? Why did I think 12:15? All right. We're going to quickly I'll show you how to make a plot. And then at the beginning of next time, we'll go through it in more detail, or you can work on it. That's what we'll do. You'll do it for homework, and then you can email me if you have questions, but you can have your results ready for next week. So I'm going to just run this to show you what it's going to look like, and then we'll talk through what's going on. So you can run your chunk and you can see this nice box plot that's being made. So pretty. So I'm going to quickly tell you about ggplot. What is ggplot? ggplot is a popular data visualization package in R. It's extremely useful. It makes really, really pretty plots. And you can also like put them all together. Like you can make a box plot and a line graph and a circle plot, and you can put them all together in one figure. So it's very useful. So if you can learn how to use ggplot, it'll be really helpful. No, is everybody okay? Good. Okay, cool. So this is a box plot, and what is happening, the basics of ggplot, you have to load the library. You already installed the package, so you don't have to reinstall the package, but you have to load the library, ggplot2. Then the basics are, you include your data. Then this aesthetics argument, you have to have the x-axis and the y-axis, and then you name it. So here, our data is named group. That's on our x-axis. We have 4 groups. And here the values are on the y-axis. This is just like mock data. So it's just made up numbers, but we're going to use real data in a minute. And so you can see that we're giving ggplot function the data set, and then we're telling it what the x-axis is going to be and what the y-axis is going to be. So the x-axis is going to be our 4 groups, and the y-axis is going to be the values that each group has. And then we're going to, the framework of a ggplot starts this way every single time, no matter what kind of plot you're making. And then you tell it what kind of plot you want to make. So here we want to make a box plot. So then you have to say, plus this box plot. And then you want to, do you want an x-axis label? You have to tell it. So you say plus an x-axis label, and that's going to be group. And then if you want a y-axis label, you say plus a y-axis label, and that's value. And if you want a title, you tell it plus this title. And so when you do all that, you get this nice plot. So there's lots of ways to play around with this. But what we're going to do is you're going to read in this genes data that I think you uploaded already. So you should just be able to read it in. So Dana, what is this data showing?
I don't have it uploaded, so I have to upload it.
Ah, okay. Who has
Oh
it?
yeah,
up?
where is that
It was in the Zoom chat.
GAPDH? Oh, in the Zoom chat. I must
Wait, what are you?
wait. Oh, you can hear me, right?
Yeah. Did you
Oh.
get it?
No, I'm just confused. I'm trying to right where it said, where is it? Upload the 51, create the GAPDH box plot.
Yes.
Where is that file or data? How do you?
The genes fpkm.csv file.
Oh, that's what it stands for. Oh, okay, never mind. I got it.
No, it's okay.
I just didn't know what that stood for. Okay.
Yeah,
I'm good
so
now.
GAPDH is, I didn't change the name actually. It read in genes data. There we go. Please change that if you want. That'll be more clear.
Okay, I'm good. Thank you.
Okay. Are you all okay staying a couple more minutes, or do you want to leave at 12? Because we can stop like exactly at 12, or we can finish. It's up to you.
Yeah, we'll finish.
Okay, yay, because you'll like the end product. It's very pretty. So we have 3 columns. So Kylie, did you get it uploaded?
Yes.
Great. And did you run this code?
Yeah, I'm good now.
Great. So what does it say in the table?
Hold on. Like, what does it mean?
Yeah, what is it representing?
I don't know. I don't know.
That's okay. We have 3 columns. The first column is the experiment group. So that was like the BC group, the BC docs group, and we'll have the DL group and the DL docs group. So it's like the table's now switched, and we're looking just at 2 genes instead of all the genes. So we're looking at GAPDH and we're looking at H19. So we're only interested in the gene expression data for these 2 genes now out of all of the data.
Gotcha.
Katie, you all right?
I recognized the protein from a class I took last semester. I was like,
Yeah. So you all can, and if anyone does Western blots, I'm sure you recognize GAPDH because it's a very commonly used gene, protein to probe for. So we're gonna use the 2 packages. You already have ggplot loaded, so you don't have to worry about that one. We're gonna install this really cool package for our color palette called Palette Town. So make sure you load that. And it's actually the colors of all the Pokemon. I don't know if anyone likes Pokemon. So you can play around with this after today and pick your favorite Pokemon and use those colors. I just learned about this and I was really excited. So pick out all of them. We're gonna use the Pokemon, which one? 137. Who is 137? Where are you, 137? We're using Porygon. I don't know who that is actually. Okay, so the first thing we want to do is save our color palette here, make our colors. So we're going to use the Porygon Pokemon and then just 4 of those colors. And then I want to run my ggplot. So remember, I'm giving it the data. We're using the genes data. The x-axis is going to be the experiment group. That's what the column name for the x-axis was, if you recall. Then our y-axis, we want to do a box plot on gap DH. So that's what we're going to run on the y. And then you add this extra argument for color. So we're going to fill it with our based on the experiment group. So we want each of the different experiment groups to be a different color. And that's why we're doing that. And then we're making a box plot, same as before. We're using X label will be group and Y label will be gap DH FPKM. And then you have to add this extra part for colors. And in that argument, you say the value of my colors equals my colors, which you already assigned up here. And then when you run it, it says one or more packages need to be updated. Oh no, you're not supposed to say yes. You should say no, don't say yes. So then when you run it, you should get this really pretty plot. Woo! So what do we observe from this plot? What is gap DH? Like the expression of gap DH, what can you get from this information?
The DL has the highest one.
The highest
And it has, like-
expression levels, right?
Yeah, and it has the lowest like standard deviation.
That's true, yeah. So there's, for some reason, the experiment DL has the most gap DH expression. And then BC has the lowest gap DH expression. This is really concerning because gap DH is supposed to be a housekeeping gene. Have you all heard that term before? Yeah. And so you use it in Western blots to normalize all your data. And so if gap DH is variable, you can't normalize your data to that. That's very concerning. So I don't know what was going on in this experiment. And so for homework, you guys can make your own plot for this other gene, H19. So you all will work on that and you can bring it back next week to show us. And please choose whatever fun color scheme to use. So that was that. Before we stop, let's just go around the room and see what you guys want to make your projects on for next week. So I can help prepare for you all to make those. So Dana, you're first on my list.
Are we like, is it just like any graph? Like what?
Yeah, so I don't know if you came prepared with like an example that you want to do, or if there's something like just an idea you want to try to make.
Okay, well this one, I don't actually know if we can make this. I don't know. But this was in the textbook for my class. Okay, no, you can't see that. Hang on.
Wow, that's so cool.
Wait, could you see it? Yeah.
I did see it, yeah.
Oh, okay, yeah. So I don't really know what data he used or like anything. But it's kind of cool.
It is really cool. So that comes, can you send me that file? Like
yeah, this is like
the
a PDF,
right?
So like this is like the textbook that we use for our class, and
Yeah.
it made no sense to me, but
Oh my gosh,
okay.
the math makes no sense to me,
Yeah.
but we
Yeah,
could
there's a
maybe
lot
make
going
the
on.
figure. Do you have a backup if this is too complicated?
I don't, I just can look at anything. I was like, I don't really know if anything would be like applicable to like what I'm doing in my lab right now, but
You said you
Um,
were doing some tissue culture like experiments. Do you have any results you might want to make a plot from?
not yet. I'm like analyzing some Western blots right now, so I could do like kind of what Catherine was doing, like the line graphs or like a bar
Yeah,
graph.
like different treatments or something.
Yeah.
Okay, yeah, if you want to bring, so send me this and I'll look at it. But then also
Mhm.
if you want to bring some results like of like over time results or whatever. Or if you, and I think Will was doing this too, if you have like Western blot like density values for different experiments, we could do like different, like you could do either box plots or a heat map of that data. So
Okay, yeah.
okay. So just like write those two things to email me if you don't mind. Okay, Catherine.
It is funny that you said the line plot, because that's what I was thinking, because I pulled up with like one of the girls in my lab, her, like she did line graphs from what I've, like the stuff I'm repeating now. So I thought it'd be
Nice.
interesting to do line graph.
Yeah. No, that's great. Could you send me that figure?
Yeah.
As a file? Okay, great. I just want to make sure like I can make sure you have everything you need to do that. Do you have data that you'll bring?
Yeah, I think I
okay.
shall be able to.
Okay, cool. Great. Kylie.
I guess probably for me, I'm gonna try and keep it simple of like maybe like just a bar graph or something to represent if I have a lot of PCR, I
Yeah.
guess maybe represent like the band lengths, I guess would be. Actually, I don't really know how to represent it, but I was thinking just something simple.
How many, like, is it that you made a bunch of constructs and so you want to choose like the best one? Is that what you're trying to represent?
So I only have one construct, but multiple plasmids, so I could compare
Sorry.
which
Yeah.
plasmid took up the construct, I guess, in comparison to each other.
Yeah, I think a bar plot's a great idea. And I'll think of other ideas if you want to play around with something else too. So I will think about that.
Okay.
Cool. Katie.
I think the data that I've collected this summer is probably going to be best represented by just like a bar graph, maybe by like density of like Western blots.
Mm.
But I have a question sort of for like personal data for like a project that I have going on like back at my home university.
Mhm.
And I was wondering if I've got like, could I represent velocity change over time using this?
Yeah.
And
Yeah. So like Catherine's going to be doing a line graph and maybe Dana too. So we could like, I could go over a line graph section at first or something so that you all could like, whoever wants to work on the line graphs could do that. And then if that's something you want to do as well as the bar plots, you could definitely do that too. Yeah,
thank you.
of course. I'm so excited you all like have something you want to work on. That's great. Will, what about you?
Yeah, I'm kind of along the lines of Kylie and Katie too. Just kind of, I think the graphs look really good. I even showed them to the one person in my lab. He's like, that looks like an actually what they put in a journal.
Yeah.
So I think definitely something along the lines of just the visuals. I think they look awesome in R. So just kind of getting practice with that. Because if that's like the main takeaway that I can remember in like 2 years, then like I feel like that's really beneficial.
So which plot do you want to do?
Whatever. Like
Okay.
whatever graphic.
Do you
I'm
have
down for
data
the
that you
graphic.
would bring though? Like you have data that you might bring?
No, I don't have any data yet, to be honest.
Okay.
There's been like problems the past 4 weeks with the equipment. So just kind
Cool.
of sliving at this point, you know?
That's okay. I will bring some extra data so we can have people that don't have something they specifically are working on can use if they want to. Guys, I didn't show you the most important part, which was the report. So when you're done with this whole thing, make sure you click knit. And then it puts everything you did today in a report and all the code and all of the results. And at the end, it shows you all your plots. So this is gonna, when you finish the real thing, you'll have a plot, you know, your version, you'll have a plot here too. So you can save this as like you can always click on it, or you can publish it as something, which I don't know, I don't know what to do about that, but you can, I think, save it as like a file as well. Isn't this awesome? So cool. Be like, hey, look, PI, look at all this stuff I did today. I'm so smart. Cool. Well, email me if you have any questions in the meantime, but I will be prepared to help you out with definitely line graphs and bar plots. And then for Dana, I'm going to see what that plot is, and then we're going to go from there. Sounds good. Have a great weekend.
Thank you.
Thank you so much.
Yeah.
Have a good one.